You're asleep in a tent. There's a wall of nylon between you and a forest full of animals that can hear your heartbeat, smell you from a mile out, and see perfectly in the dark while you're lying there completely unconscious. And yet, you wake up every morning. A sleeping human is, by every biological measure, helpless, slow, unaware, can't run, can't fight. You'd think predators would be circling campsites every night. They're not. And the reason isn't one thing. It's several layered reasons that go back millions of years. We're going to cover the fear that's been wired into their genetics, why you smell like nothing in their system, and the risk math that makes a sleeping human a bad target. Sounds like ego. It's actually just data. In 2019, researchers at UC Santa Cruz played audio recordings of human voices near mountain lions in the Santa Cruz Mountains. Normal voices, people talking. The pumas fled. They fled at the same rate they fled from barking dogs, and in many cases faster. These are animals that pull down full-grown deer without much trouble, and they heard a human conversation and left. The same study showed pumas abandoned kills they were actively eating when human voices played nearby, left food on the ground, and moved away. For a predator, giving up a kill means all the calories burned to make that hunt don't come back. They paid that cost anyway, because being near us felt worse than being hungry. The same pattern shows up across species and continents. Lions in Kruger National Park reduce movement in areas with higher human activity. Tigers in India give wide berths to villages sitting in the middle of prime habitat, land they'd otherwise occupy completely. Jaguars in the Amazon reroute their movement around places where humans are regularly present. None of these animals lack the ability to attack. They've made the same calculation across thousands of generations. Being near us isn't worth it. The reason for that goes deep into natural history. Humans have been hunting large predators for roughly 2 million years. We hunted mammoths out of existence. We wiped megafauna off entire continents. Giant sloths, woolly rhinos, cave bears, species that had survived multiple ice ages, gone within thousands of years of humans arriving. In North America, we drove wolves to near extinction across the entire landmass. We eliminated mountain lions from the whole eastern half of the continent through shooting, trapping, and poisoning, carried out so systematically and for so long that it reshaped which animals survived. Natural selection did the rest. Predators that approached human camps too boldly got killed. The ones that kept their distance survived, reproduced, and passed that caution forward. Over thousands of generations, it stopped being learned behavior and became instinct, a wired-in baseline that runs before conscious thought. So when a leopard picks up your scent at night, somewhere deep in its nervous system, an old alarm fires. Not a deliberate decision, an inherited signal that says, don't engage, move on. Every ancestor of that leopard that survived a close encounter with humans passed that signal down. Predators don't experience smell the way you do. Bears have a sense of smell, estimated to be roughly 7 times stronger than a bloodhound's. Wolves can pick up scent nearly 2 miles out under the right conditions. Big cats have a structure in the roof of their mouth called the Jacobson's organ that lets them pull chemical information out of the air and process it at a level we have no real equivalent for. When one of these animals gets close to a sleeping human, it receives a flood of olfactory data, and most of it doesn't match anything in the natural world. You smell like synthetic fabrics, nylon, polyester, whatever chemicals were used to manufacture them. You smell like the food you ate hours ago, the snacks still in your bag, soap, shampoo, sunscreen, insect repellent. That's a chemical cocktail with no analog anywhere in a predator's environment. And underneath all of it, you smell like a primate, which is something, but it's not the thing. Not the deer, not the wildebeest, not the animals their predatory systems have been calibrated to hunt over millions of years. A predator's hunting instinct isn't a vague drive to attack things that move. It's tuned to specific signals, the movement pattern of an ungulate, the shape and speed and smell of prey it has hunted thousands of times. You don't fit the pattern. You're an anomaly, and anomalies trigger caution, not aggression. The fear of fire isn't learned. It's innate across virtually all land animals. Animals that avoided fire survived wildfires. The ones that didn't. That fear got selected in so hard that lab-raised animals who have never encountered fire in their lives still show avoidance when they smell smoke. It goes that deep into the code. Humans have been sleeping next to fire for somewhere between 1 and 2 million years. A campfire broadcasts a signal into the surrounding dark. Something is here that controls fire. Predators have received that signal long enough that it no longer needs processing. It just triggers avoidance. Fire came before pottery, before farming, before writing. Turns out that was the right order. Movies keep getting this wrong. Predators aren't fearless killing machines. Large predators are careful, not because they're timid, but because they can't afford not to be. A lion doesn't have a vet. A wolf doesn't recover from a broken leg at home. One serious injury in the wild, a damaged eye, a deep bite wound, a fractured limb, means the animal can no longer hunt effectively, which means it starves. Every engagement with potential prey is a survival calculation. Is the caloric value of this target worth the risk of getting hurt? A sleeping human fails that calculation in 3 ways. First, unfamiliarity. A predator is most confident attacking prey it knows well. It's watched a zebra hundreds of times. It understands how the animal moves, where its blind spots are, how it panics, and which direction it runs. A human is none of that. You might wake up screaming, you might have something in your hand, you might have 3 other humans nearby who respond. That level of unpredictability is a serious red flag for an animal whose survival depends on clean, low-risk kills. Second, your shape. Standing upright is a threat display in the animal world. It's what gorillas do to intimidate, what bears do when they want to look dangerous. A creature whose default posture looks like a threat display reads as assertive, even lying down. The silhouette of a human at rest doesn't say easy meal. Third, opportunity cost. A predator with a healthy territory has access to prey it knows and is comfortable hunting. Going after something unfamiliar and potentially dangerous when there's a known animal nearby makes no survival sense. Your sleep also isn't as passive as it feels. Human sleep runs in cycles. You drop into deep, slow-wave sleep, then rise back into lighter stages. And during those lighter stages, your brain stays surprisingly active. Researchers call this the sentinel function. Your brain keeps filtering sensory input while you sleep, and it flags unfamiliar signals faster than familiar ones. A loud twig snap, a large animal moving through brush, a shift in air pressure. These things can pull you toward waking faster than you'd expect. That's not an accident. The people in our evolutionary history who slept too deeply didn't survive long enough to have descendants. Lighter sleepers did. So human sleep got tuned over hundreds of thousands of years to stay just responsive enough to threats in the dark. You're running a low-level early warning system even when you're unconscious. Predators don't just attack prey. They hunt for separation, the isolated animal, the one cut off from the herd, the one that's fallen behind. A camp of sleeping humans is a group that wakes collectively. One person jolting awake pulls the others up. That collective response, chaotic, loud, unpredictable, is exactly what a predator calculating risk wants to avoid. When attacks do happen, the system broke. A predator that's injured and can no longer take its normal prey. One that's starving because its habitat has collapsed and its usual food sources are gone. Or one that's been fed by humans enough times that the inherited wariness eroded. The Tsavo lions in 1898 killed dozens of railway workers over 9 months. But both were atypical. One had severe dental damage that made hunting its normal prey nearly impossible. The Champawat tiger, responsible for an estimated 436 deaths across India and Nepal, was found to have 2 shattered canine teeth from a gunshot. Both animals had been pushed by injury into hunting the only prey they could still physically manage. The rule didn't fail. The conditions did. The UC Santa Cruz study found something beyond the puma behavior itself. When pumas pull back from human zones, deer face less predation. Populations rise, vegetation gets overgrazed. Medium predators, coyotes, foxes, bobcats, also reduce their presence near humans, so the rodents they normally control start expanding. One inherited fear in one species cascades through the entire food web. You don't need to interact with any of those animals directly. Just being there does it. The thing in the dark isn't coming in. Not because you got lucky. Because you carry 2 million years of predator pressure in your biology, and the animal outside your tent carries the same number of generations telling it to leave you alone.